Imagine this. You're an engineer, and someone walks into your office one day and says, "Hey, we need you to design a tiny robot, strap it to a rocket, and launch it millions of miles to Jupiter. Oh, and make sure it survives deadly radiation, avoids crashing into one of Jupiter's 79 moons, and sends us cool selfies from space." Easy, right? Yeah, no pressure at all. Now you might think, why even bother? Jupiter's just a giant ball of gas, right? Well, here's the thing. Jupiter holds some of the biggest secrets of our solar system. It's got hurricane-like storms that have been raging for centuries, a magnetic field that could fry your phone in seconds, and moons that might just be hiding alien life beneath their icy surfaces. This isn't just another space mission, it's a cosmic treasure hunt. And today, we're going to dive into all the crazy, exciting, and downright mind-boggling challenges that come with sending a probe to Jupiter. Trust me, after this, you'll never look at space the same way again. Alright, let's get one thing straight. Jupiter is ridiculously far away. We're not talking about a quick trip around the block here. No, this is 600 million kilometers away on a good day. That's so far, it's like driving non-stop for 24 hours a day for 70 years. Except you'd still run out of road somewhere around Pluto. Yep, even light, which travels faster than anything else in the universe, needs 43 minutes to get from Earth to Jupiter. So imagine how long it takes for a slow little space probe to crawl its way over there. We're not talking about months here. We're talking about years of lonely cruising through deep space. This is the ultimate interstellar road trip. Think, are we there yet? But with way more zeros on the odometer. And here's the thing. You can't just shoot the probe straight to Jupiter. Nope, space doesn't work like that. If you aim directly at it, by the time the probe gets there, Jupiter will have already moved on, minding its own giant gas business somewhere else. So you have to plot this ridiculously complicated path that curves through space, taking into account planetary orbits, gravity, and momentum, like you're planning a cosmic game of pool. And let's be real, if you miss your target, you can't exactly hit reverse and try again. "Houston, we missed Jupiter" isn't something anyone wants to hear over the radio. And that's just the distance problem. Once the probe finally reaches Jupiter after its years-long journey, it still has to do some pretty fancy space choreography to enter orbit, without crashing, flying by too fast, or getting yanked off course by Jupiter's enormous gravitational pull. Think of it like parallel parking, but you're moving 60,000 kilometers per hour. And if you miss, you'll probably end up somewhere in deep space, never to be seen again. Now that you know just how far Jupiter is, let's talk about how we actually get there without running out of fuel halfway through. Spoiler, we cheat. Well, not exactly cheat. Let's call it being cosmically resourceful. This trick is called a gravity assist or slingshot maneuver. And trust me, it's as awesome as it sounds. Basically, we borrow some energy from nearby planets, like a kid using their friend's swing to launch themselves higher into the air. But instead of swings, we're using entire planets to fling the probe across the solar system. No big deal, right? Here's how it works. The probe zips past a planet like Venus, and the planet's gravitational pull gives it a nice little speed boost. It's kind of like the planet gives the probe a cosmic high five, saying, "You've got this, buddy. Now fly." But of course, it's not as easy as just flying by and waving hello. Everything needs to be timed perfectly. If the probe gets too close, it risks being sucked into the planet's gravity and becoming an expensive piece of planetary junk. Too far, and it just drifts away into the endless void of space. And no one wants to explain to Mission Control that their billion-dollar spacecraft is now lost somewhere between Venus and nowhere. But when it works, it's a thing of beauty. These slingshot maneuvers can save tons of fuel and shave years off travel time. The probe builds momentum, using the energy of planets like Earth, Venus, or Mars to catapult itself toward Jupiter. If everything goes according to plan, it arrives at Jupiter with just enough fuel to fine-tune its orbit. If not, well, let's just say there are no pit stops in space. Imagine being halfway to Jupiter and realizing, oops, we forgot to fill the tank. Not a great day for the mission team. But it's not just about getting to Jupiter faster. It's also about precision. We're talking calculations down to the second. If the probe is even a fraction of a degree off course during a gravity assist, it could overshoot Jupiter completely and end up on an impromptu road trip to Saturn or beyond. And while Saturn's rings are pretty, that's not exactly where we're trying to go. The slingshot trick is like playing interplanetary billiards, but with planets as the balls and gravity as the pool cue. And if the probe makes it through all these precise maneuvers, it's finally on a direct path to Jupiter. Now the real fun begins, because surviving the journey there is just the first half of the challenge. The next step, surviving Jupiter itself. Now let's say your trusty little space probe has navigated all the tricky slingshot maneuvers and made it to Jupiter. First of all, congratulations. That's no small feat. But now things are about to get a whole lot more dangerous. Why? Because Jupiter isn't just the biggest planet in the solar system, it's also one of the most dangerous. And the main reason for that? Radiation. Lots and lots of it. Think of it like this. If Earth's radiation belts are the equivalent of a sunny day at the beach, Jupiter's radiation belt is a microwave turned up to max power. And guess what? Your delicate little space probe is the burrito in this scenario. Jupiter's magnetic field is the largest and strongest in the entire solar system. It traps high-energy particles from the sun and creates a radiation belt so intense that even the most advanced electronics struggle to survive. And just to make things worse, this radiation belt is spinning faster than your blender during smoothie season, so any spacecraft flying too close to Jupiter risks getting zapped and fried faster than you can say, "Houston, we have a problem." Let's just say radiation insurance isn't something you can easily buy for a space probe. To survive, space probes like Juno are wrapped in special radiation shielding, almost like wearing cosmic armor. This keeps the electronics safe from Jupiter's relentless particle storm. But here's the catch. More shielding means more weight, and as we know by now, more weight means more fuel. And remember, you can't exactly pack extra fuel for this trip. It's kind of like trying to road trip across the country with a car full of bricks and only one tank of gas. So instead of just piling on shielding, engineers have to carefully plan the probe's path to dodge the worst parts of Jupiter's radiation belts. It's like threading a needle. Except the needle is spinning at 45,000 kilometers per hour and filled with electric sparks. The good news is, when we get it right, the payoff is incredible. Thanks to Juno, we've already gotten jaw-dropping images of Jupiter's swirling storms, including the Great Red Spot, a storm that's been raging for centuries, and that's just the beginning. Imagine what future missions could uncover if we survive the radiation long enough to explore Jupiter's moons. Think of it this way, if we can handle Jupiter's radiation belt, we're basically the Indiana Jones of the solar system. So, dodging radiation around Jupiter is kind of like riding a bull at a rodeo. One wrong move, and you're toast. But if the probe makes it through, it's still not out of the woods. Because now, it's time to meet Jupiter's entourage, and they're not exactly the welcoming kind. Up next, 79 wild moons, each with its own personality. Some with oceans, some with volcanoes, and all of them ready to throw a wrench in our mission. Alright. So your probe has survived the slingshots, dodged deadly radiation, and is now cruising comfortably around Jupiter. Mission accomplished, right? Not even close, because Jupiter isn't just a lone giant. It comes with a chaotic entourage of 79 moons, and these aren't your typical, boring rocks floating in space. Oh no, each moon is a character of its own. Some are spewing lava, some are hiding oceans, and all of them are ready to complicate your mission. Think of it as hosting a party with 79 guests, and each one has wildly different ideas of what counts as fun. Let's start with Io, the drama queen of Jupiter's moons. Io is the most volcanically active body in the entire solar system. Picture this. Its surface is constantly erupting, spewing lava that shoots hundreds of kilometers into space. It's basically a volcanic theme park, minus the safety regulations. Trust me. You don't want to park your probe too close to Io unless you're in the market for some fiery selfies. Then there's Europa, the introverted sibling with a secret. Europa is covered in a thick layer of ice, but scientists believe there's a vast ocean lurking beneath that frozen crust. And where there's water, there could be life. Yep, that's right. Europa just might be hiding some alien fish under all that ice. And we're dying to find out if they're swimming down there, waiting to greet us. Though, honestly, if we meet some alien life, let's hope they're friendly. Because I don't know how well Earthfish translate into, "I come in peace." And then there's Ganymede, the overachiever. Ganymede isn't just the largest moon in the solar system. It's so big it has its own magnetic field, Like, who does that? Even Mercury doesn't have a magnetic field, and it's an actual planet. Basically, Ganymede is the kid who brought a science fair project so impressive that even the judges are like, okay, we get it, calm down. But wait, there's more. Callisto is another moon covered in ancient craters, and some of the smaller moons orbit in all kinds of weird patterns, like they never got the memo on how to circle a planet properly. Trying to navigate around Jupiter's moons is like walking through a room full of toddlers running in every direction. You just hope you don't bump into one by accident. Here's the problem. Each of these moons has its own gravitational pull, and if your probe flies too close to one, it could get yanked off course. Engineers have to carefully map out the orbits of every single moon to make sure the probe stays on track and doesn't end up accidentally crash landing on Io, roasting like a marshmallow. And believe me, that's not a conversation you want to have with mission control. So, funny story, we landed on the wrong moon, but the payoff is huge. Each moon is like a mini world of its own, filled with mysteries just waiting to be unlocked. If our probes can survive the chaos, we might discover things that change how we think about the universe forever, like what's hiding beneath Europa's ice, or how Io manages to stay so volcanically active. Every discovery brings us closer to answering the big questions, like, could life exist beyond Earth? Honestly, exploring Jupiter's moons is like opening a cosmic treasure chest. Who knows what we'll find? So yeah, Jupiter's moons are no joke. They're wild, unpredictable, and each one brings a new set of challenges. But that's exactly why they're so exciting. Every moon holds the potential for groundbreaking discoveries, and maybe, just maybe, a hint that we're not alone in the universe. And isn't that what makes space exploration worth all the trouble? After all, no great adventure is without a few challenges, and in this case, a few dozen moons. Now that we've dodged moons, survived deadly radiation, and we're closing in on Jupiter, but there's still one huge challenge left. Fuel. Managing fuel in space is like trying to pack for a 6-month vacation using only a carry-on bag. Every gram matters. It's not like we can slap a sticker on the probe saying, add more fuel if needed, and hope for the best. Once the probe leaves Earth, it's on its own. So, every bit of fuel has to be used efficiently. Here's the thing, if you carry too much fuel, the spacecraft becomes too heavy. And the heavier it is, the harder it is to move, which means, you guessed it, you need even more fuel to move it. It's a vicious cycle that every mission planner has nightmares about. Honestly, packing for space makes Marie Kondo look like an amateur. So, to conserve fuel, probes use these tiny bursts of propulsion to adjust their course. Kind of like tapping the brakes just enough to stay in the right lane on a highway. But every little maneuver eats into the limited fuel supply. And running out of fuel halfway to Jupiter, that's not an option. Imagine spending billions on a probe only for it to become an expensive paperweight drifting through space for eternity. Not exactly a proud moment for NASA or ISRO. And it's not just about getting there. Once the probe reaches Jupiter, it still needs enough fuel to slow down and enter orbit. Without the right speed, the probe will zip right past the planet like a driver missing their freeway exit. And trust me, there's no U-turn in space. Can you imagine the probe calling Earth? Yeah, we kind of missed Jupiter, but hey, Saturn looks nice this time of year. But fuel isn't the only thing to worry about. There's also the question of what instruments to bring. Every mission wants to carry as many scientific tools as possible, cameras, sensors, spectrometers, you name it. But the more stuff you bring, the heavier the probe gets. And that means, yep, more fuel needed. It's the ultimate balancing act between science and logistics. It's like trying to decide between bringing your camera or an extra pair of shoes on vacation. But in this case, the stakes are a bit higher, like billions of dollars higher. Engineers also have to account for Jupiter's massive gravity. If the probe isn't traveling at just the right speed, Jupiter's pull could send it into an endless spiral, or worse, smash it into one of its moons. And explaining to mission control that Jupiter ate the probe is definitely not the way you want to end a mission. But when everything goes right, it's like a perfectly choreographed dance. The probe enters orbit, deploys its instruments, and begins sending back priceless data, unlocking secrets about Jupiter and its moons that we've been chasing for decades. And the best part? We did it with just enough fuel to get there, get the job done, and send back selfies from space. Not bad for a little metal box traveling hundreds of millions of kilometers, huh? So yeah, managing fuel, weight, and mission logistics isn't just rocket science. It's a mix of precision engineering, high-stakes decisions, and a bit of luck. But when you pull it off, the rewards are out of this world. Literally. And now the real fun begins. Analyzing all that juicy data, discovering what makes Jupiter tick, and if we're lucky, getting one step closer to answering the ultimate question, is there life beyond Earth? Because if there's one thing space teaches us, it's that the journey is just as exciting as the destination. Alright, so the probe made it. It survived the deadly radiation, dodged moons, didn't run out of fuel, and is now happily orbiting Jupiter. So what's next? Now comes the exciting part, collecting data. And let me tell you, there's a reason scientists go through all this trouble. Jupiter isn't just some giant gas ball. It's a treasure chest of secrets that could rewrite what we know about the solar system. Why is Jupiter such a big deal, you ask? Well, buckle up. We're diving into some truly mind-blowing stuff. First up, the Great Red Spot. This is no ordinary storm. It's a massive hurricane that's been raging for at least 300 years, and it's so big that Earth could fit inside it. Yeah, you heard that right. An entire planet could fit in one storm. But here's the kicker. We still don't know exactly what's driving it or why it's been spinning for so long. Is it some kind of alien weather machine? Probably not, but we won't know for sure until we take a closer look. And let's be honest, who wouldn't want to know the secret to a 300-year-old storm? Could be useful for Earth's meteorologists, right? Then there's Jupiter's atmosphere, a chaotic soup of hydrogen, helium, ammonia, and methane. But here's the thing. No one really knows what's beneath those thick clouds. Does Jupiter have a solid core deep inside, or is it just gas all the way down? Uncovering that mystery could help us understand how planets form and even offer clues about how Earth ended up with the conditions necessary for life. Basically, figuring out Jupiter's atmosphere is like trying to guess what's inside a piñata, except the piñata is 318 times heavier than Earth and filled with science. Now let's talk about Europa, one of the most tantalizing objects in the entire solar system. Scientists are almost certain that beneath its thick layer of ice lies a liquid ocean, potentially filled with the ingredients for life. If we find even the tiniest microbe swimming around under there, it would be one of the biggest discoveries in human history. It would mean we're not alone in the universe. Imagine that. A probe traveling all the way to Jupiter just to find out we have neighbors. Alien fish, anyone? And let's not forget about Ganymede, another moon with a potential ocean lurking beneath its icy shell. But Ganymede has something extra, a magnetic field. That's huge because it could mean Ganymede's ocean is protected from Jupiter's deadly radiation, giving any potential life forms a fighting chance. If there's life on Ganymede, they might be the luckiest aliens in the galaxy, shielded from both radiation and tourist probes. Future missions plan to land on Europa and drill through its ice to sample the ocean beneath. It's like opening a cosmic treasure chest, and who knows what we'll find. Even if we don't discover life, every bit of data brings us closer to understanding how planets evolve and whether life could exist elsewhere in the universe. And let's face it, if we find even one weird microbe swimming around on Europa, it's game over for those who said we're alone in the universe. But the science jackpot doesn't stop with the moons. Jupiter holds the key to understanding how the solar system formed. Its massive gravity has been shaping the orbits of other planets for billions of years. If we crack the mysteries of Jupiter's formation, we might even get clues about how Earth ended up in the perfect spot to support life. Think of Jupiter as the solar system's biggest influencer. Without it, Earth might have been just another lifeless rock drifting through space. The data we've already gathered from missions like Juno is just the tip of the iceberg. Every new mission brings us closer to unraveling the secrets of Jupiter and its moons. And who knows, one of those secrets might just change the way we see the universe forever. Now tell me that's not worth all the trouble of sending a probe across 600 million kilometers of space. So yes, exploring Jupiter is insanely hard. It takes years of planning, mind-blowing engineering, and a whole lot of patience. But the rewards, absolutely priceless. Whether it's unlocking the secrets of Jupiter's atmosphere, discovering alien oceans under Europa's ice, or learning how the solar system came to be, it's all worth it. Besides, if we don't explore, how else will we answer humanity's biggest question? What else is out there? Because when it comes to space, every mission is about more than just science. It's about pushing the limits of what's possible, asking the big questions, and daring to go where no one has gone before. And hey, if we find some space fish along the way, that's just a bonus. So why do we do it? Why pour billions of dollars and years of effort into sending tiny metal probes across the unforgiving void of space? Why risk failure, knowing how hard it is to get there? Because, at the end of the day, it's not just about Jupiter, or Europa, or Ganymede. It's about us. It's about who we are as a species. We've always been explorers. From the moment humans first looked up at the stars, we've been curious. What's out there? What lies beyond the next horizon, the next ocean, the next planet? And sure, sending a probe to Jupiter might seem like overkill just to answer those questions. But hey, if you're going to dream big. Every time we send a spacecraft to a distant world, it's not just about science. It's about pushing the boundaries of what's possible. It's about saying, yeah, it's hard, but we're doing it anyway. Because space exploration isn't just about where we go, it's about what we learn about ourselves along the way. When we ask, could life exist on Europa? We're really asking, what makes life special here on Earth? When we study Jupiter's atmosphere, we're learning more about how planets like ours come to exist. And when we brave the dangers of space, we remind ourselves of one simple truth. We thrive on challenges. And that's the thing about missions like this. They remind us of what's possible when we come together. It takes scientists, engineers, astronomers, mathematicians, artists, dreamers, everyone working toward a single goal: to explore, to learn, and to push forward. And let's be real. If we do find life on Europa, the people who made this mission happen will have the ultimate bragging rights. Imagine being able to say, yeah, I helped discover alien fish. No big deal. But it's not just about the discoveries. It's about the spirit of exploration itself. The same spirit that took us to the moon, that's driving us to Mars, and that will one day take us even farther, maybe to the stars. Because if there's one thing we know for sure, it's this. We were born to explore. It's in our DNA. And as long as there are mysteries left to solve, we'll keep asking questions, building spacecraft, and sending them to the farthest reaches of space. And who knows? Maybe someday we'll go beyond Jupiter, beyond our solar system, and discover things we can't even imagine yet. So yeah, exploring Jupiter is hard, really hard, but that's what makes it worth it. Because every mission, no matter how difficult, brings us closer to understanding who we are and what our place is in the universe. And if that means sending a tiny probe millions of kilometers away just to learn a little more, well, then that's exactly what we're going to do. Because at the end of the day, space exploration isn't just about where we go, it's about how far we're willing to dream. And dreams, well, they have no limits. See you on the next mission.